Hello everyone. Today let us discuss about AC voltage applied to an inductor. In last class we have discussed about AC voltage applied to a resistor. There we have discussed all the points, and I also told you in the introduction, for every circuit we need to write 5 equations definitely. What are those 5 equations? Number 1, voltage equation, and number 2, current equation, and number 3, resistance of the circuit, and number 4 is phase difference between voltage and current, and number 5 we have power through the circuit. These are the 5 points which we have to write for every circuit. If you want to know, you can see my previous video. And also for every circuit we need to draw 3 figures. Those figures are: number 1, circuit diagram, number 2, wave diagram, number 3, phasor diagram. So these 8 points are compulsory for each and every circuit. Okay. So now today let us discuss about the AC voltage applied to an inductor. First let us draw the circuit diagram. So the circuit diagram is simple. This is our AC voltage. It is applied to an inductor like this. It's over. That's all. This is the applied voltage. V is equal to Vm sine omega t, and this is the inductance coil. Very simple circuit, nothing serious here, very easy one. So we know the Kirchhoff's second rule, the algebraic sum of the voltages and the EMFs, that is algebraic sum of the EMFs and potential differences around a closed loop, is equal to 0. Mathematically we write it as sigma E of t is equal to 0. So now what is the EMF here? EMF is the voltage, that is the V is equal to Vm sine omega t, which is applied. Whole applied voltage appears across the inductance, because inductance is the only one which is existing in the circuit. Therefore all the applied voltage appears across the inductance. Therefore we can write Vm sine omega t, that is applied voltage, appears across the inductance. Voltage across the inductance is L into di by dt. Okay, so first we will write the applied voltage equation here. V is equal to Vm sine omega t, and give it equation number 1, and now let it be equation number 2. Okay, now after that we want to know the next one is current equation. To know the current equation, let us utilize equation number 2. Okay, now set dt this side, you will get now, that is Vm sine omega t dt is equal to L into di. Okay, and we want to know the current. So let us send this L also to the left side. You will get Vm by L sine omega t dt is equal to di, or else you can also write it as di is equal to Vm by L sine omega t dt. Okay, now to know the current, integrate both the sides. Therefore you will get integration of di is equal to integration of Vm by L sine omega t dt. And you know integration of di is I, and Vm and L are constants. Take them out, integration of sine omega t dt. And you know in maths trigonometry, you all know very well, that is integration of sine theta d theta is equal to minus cos theta. You all know that. So let us apply the same thing here, and we get from here I is equal to Vm by L, that is minus cos omega t, and divided by omega as per the integration rules. Therefore you will get now, that is I is equal to Vm by omega L minus cos omega t. let it be equation number 2. I hope so. Here we have given equation number 2, no? Okay. So now let it be equation number 3. Yeah. Let it be equation number 3. We know from trigonometry, sine 90 minus theta is equal to cos theta. So what I tell is both sides you put minus sign, here minus, and you will get LHS sine theta minus 90 is equal to minus cos theta, or 90 you can write as pi by 2, theta minus pi by 2 is equal to minus cos theta. So what is the conclusion now? When you write omega t in place of theta, you can write it as, that is a sine omega t minus pi by 2 is equal to minus cos omega t. Let it be equation number 4. Now take this equation 4, substitute in equation 3. Therefore, you will get, that is equation 4 in equation 3, you will get now. So equation 3, you can see here I is equal to Vm divided by omega L minus cos omega t. In place of minus cos omega t, we are substituting sine omega t minus pi by 2. So that is what we have substituted here. So we can rewrite it as I is equal to Vm divided by omega L sine omega t minus pi by 2. That is equation number 5. Now you can write the maximum value of current here, that is I max or Im is equal to Vm by omega L when sine of the angle, that is omega t minus pi by 2 becomes 90, then maximum value of I is equal to, yes, maximum value of current Im is equal to Vm by omega L. Okay, substitute that value in equation 5, you will get I is equal to Vm by omega L, we are writing as Im sine omega t minus pi by 2. This is the equation of the current. This is the equation of the current. So we got two equations now. One is voltage equation and the other is the current equation. Okay. Our next point is to find resistance of the circuit. Now if you see this equation, Im is equal to Vm by omega L. Compare it with Ohm's law, I is equal to V by R. In place of resistance R, you have omega L. Therefore, you can write now, that is R, that is resistance is equal to, resistance of the circuit is equal to omega L. Here we have a new name for that, reactance. For resistance we call as reactance, and this is the reactance of the inductance. Therefore, we call it as inductive reactance. So inductive reactance is equal to omega L. For that the symbol is X and then subscript L. Generally reactance is given by the letter X. Because it is inductive reactance, we are keeping a subscript of L. So this is XL. So XL is equal to omega L, that is inductive reactance. So we got our third equation. Now inductive reactance, that means it is the resistance of the circuit. It is the resistance of the circuit given by XL, that is equal to omega L. Let it be equation number 7. Yes, now we got 3 points. One is voltage equation, second is current equation, and the third is resistance of the circuit. Now let's proceed and find out the phase difference between voltage and current. We know the voltage equation V is equal to Vm sine omega t, and the current equation I is equal to Im sine omega t minus pi by 2. very clearly you can see here there is a phase difference of pi by 2, that is minus pi by 2. That means current is behind the voltage by 90 degrees. Current is behind the voltage by 90 degrees. Therefore, you can write the phase difference between voltage and current is equal to pi by 2, that is 90 degrees, whereas voltage is leading the current by pi by 2. In our previous resistance circuit, V is equal to Vm sin omega t and I is equal to Im sin omega t. There was no phase difference between voltage and current. But here there is a phase difference between voltage and current, which is pi by 2. So now we got phase difference also. And the last one what we need to know is that is power of the circuit. Now let's continue our discussion with the power of the circuit. So let us write power, and we all know power is equal to, that is because it is inductive circuit, we write PL is equal to I into V. That is I means Im sin omega t minus pi by 2. V means Vm sin omega t. Okay, you can write it as Im minus cos omega t and Vm sin omega t. Already I have shown you above how it is. Therefore, you can write it as, that is equal to minus Im Vm sin omega t into cos omega t. Now multiply by 2, divide by 2. Then you will get minus Im Vm divided by 2, 2 sin omega t cos omega t. Then if you want average power, what we have to write? In the last video I told you, you have to put them in the triangular brackets. Therefore, you can write it as now, that is average power, you can write triangular bracket minus Im Vm by 2. Here 2 sin omega t cos omega t. You know in trigonometry, no? 2 sin theta cos theta is equal to sin 2 theta. In the same way, it will become sin 2 omega t because of trigonometric rule. Now, if you see here very clearly, we can very clearly see here Im Vm by 2, they cannot be taken for average. So, take them out and you write the equation as, that is equal to minus Im Vm by 2, that is triangular bracket sin 2 omega t. Now we have to take an average for sin 2 omega t. Now in my last video also I told you this is the angle 2 omega t. 2 omega t means it is dependent on time. Time means this is a sine function and it is dependent on time. In that case, what will happen? Half cycle will be positive and half cycle will be negative. So what will happen now? For sine and cos, half cycle is positive, half cycle is negative. Then if you take average of this, that will become 0. So here also sine 2 omega t, if you take average, that is the triangular bracket, it is equal to 0. Therefore, this whole equation, that the power is equal to minus Im Vm by 2 into 0, that will become 0. That means average power is 0 because over a complete cycle sin 2 omega t becomes 0. So the average power supplied to an inductor over one complete cycle is 0. So here also we got another equation. So if you go up and see, we have done almost all the points. Everything we have done. Okay, so here we have given equation 7. No, let it be equation number 8 for phase difference, and now for power, which is 0, let us take it as equation number 9. So almost 5 points are over. That is voltage equation, current equation, resistance of the circuit, phase difference of the circuit, for phase difference between voltage and current, and the power of the circuit. All the 5 points are over. Now in diagrams, already we have drawn circuit diagram in the beginning. Now what we have to do is only the wave diagram and the phasor diagram. So let's start our drawing. So let us draw, this is the wave diagram. First I am taking, on x-axis we are taking the angle omega t, and on y-axis we will take the values of voltage and current. Voltage always it is same position as I told you earlier in my resistance circuit, it is same, whereas now current is different. You cannot draw like previous case. Now current equation is Im sin omega t minus pi by 2. That means it is lagging behind the voltage. When voltage reaches peak, that is here, this is the peak value of voltage, that is the place where the current starts. So you can draw like this. This is the current wave like this. It goes like this. And just to extend, you can draw like this. So this is the black one is the current. This is the current. And blue one is the voltage. And already in my previous video, I told you, you can see Im is equal to Vm divided by XL, that is omega L. That means peak value of current, which I am showing with light green color, peak value of current is less than the peak value of voltage, which is in the red color. So this is the wave diagram, and now we have to draw our final thing, that is phasor diagram. To draw the phasor diagram, already I told you, take any point here, any point wherever you wish to take. So take one point here and draw something like this, like this. Now I told you in the beginning, when you don't know how to draw some straight lines like this, and also another straight line like this. Now here, if you see very clearly, current comes behind the applied voltage. Current comes behind the applied voltage by 90 degrees. So you have to draw carefully now. The voltage vector at any instant of time, here it is omega t1. Voltage vector you can draw like this. With the x-axis it makes an angle omega t1. Exactly behind that, with exactly 90 degrees behind that, the current phasor is there. This is the current phasor. This is the current phasor, and this is the voltage phasor. Angle between them is equal to pi by 2, that is 90 degrees. Voltage phasor goes first, rotating anti-clockwise, and then behind that current phasor will go. So here is our phasor diagram also completed. You can have 0, pi by 2, pi, 3 pi by 2, 2 pi, and so on for your reference. So with this we have completed the phasor diagram also. So if you want to show the magnitudes, you can extend these lines, and you can also show this is the magnitude of the voltage with Vm sin omega t1, and bottom, that is you can show this one. This is Im sin omega t1 minus pi by 2. With this we have completed phasor diagram also. Shall we go up and have one round of all the equations just for our revision? First, in the introduction I told you we need to write 5 equations for each and every circuit. That is voltage equation, current equation, resistance equation, resistance value, and phase difference between voltage and current, and power equation. And the figures what we have to draw is circuit diagram, wave diagram, phasor diagram. Now we have done everything. All 5 points are over. all three figures are also over. Now if you see one by one, now let's go one by one. Now the first one is voltage equation, which we have written in the beginning. So this is the voltage equation, V is equal to Vm sin omega t. And the next one is current equation, which we got here, that is equation number 6. This is the current equation, that is I is equal to Im sin omega t minus pi by 2. So that is the current equation. Okay, and the next one is resistance of the circuit. So this is the resistance of the circuit, which is called as inductive reactance, which is equal to omega L. And then phase difference. Voltage, that is phase difference between voltage and current, is equal to pi by 2, where voltage leads the current by pi by 2. And the last one is power. Here you got power is equal to 0. So all 5 points are over, and all the three figures are also over. In the beginning there was circuit diagram, here there is a wave diagram, and also the phasor diagram. Actually these two lines are not required. After drawing you can erase them. Okay, so that's your choice, whether you keep them or whether you erase them, it's your choice. Okay, thank you for watching this video. We will meet in the next video with another topic, that is AC voltage applied across a capacitance. Thank you. God bless you all. Thank you for watching this video. God bless you all.